Hello, today I would like to talk about quality control and I will discuss control charts. So let's create a new Excel file. Okay. First, I would like to start with control chart for attributes. And these are called control chart for attributes because these attributes are values that are discrete, either, for example, inferior products versus good products and so on. And then next video, I will talk about control chart for variables. Okay, so let's start with the given information. All right. So here in this company, let's say we have invoices every day, and this company decided to do statistical sampling, and every time it takes a look at 1,000 samples or invoices. So, and then they do this exercise for 25 days to make sure that the quality is satisfied from suppliers. So day one, day two, let's say we have 25 days. And of course, you can do this every day, once a month, based on the quality. And if you have good long-term relationship with supplier or suppliers, you can decrease the frequency of this quality controls. But it's important to have quality control because once you have bad products in your facility, then you will start having quality problems, and that will create dissatisfied customers, and that will end up with losing your business. So in this case, we are counting number of inferior products, let's say in my first day, I have 1,000 controls or invoices, and out of this 1,000, I have 12 defective, 20, 29, 28, 62, 55, 75, 35, 23, 88, 86, 58, 27, 92, 10. Looks like it's a good day for me, only 10 defects. 78, even a better day, 4, 65, 99, 96, 57, 21, 19, and let's see how many we have now. I would like to have 25 of them. So I have so far 23. So let's do 18 and 15. Okay, so these are number of inferior products. These are my days and invoices. Every time I have 1,000 invoices that I control, and these are number of inferiors. All right, once we have this good information, now we can build our model. And this model is, again, as we talked about, is called control chart for attributes. All right. So first thing I would like to know is I would like to understand whether my system is in control. So in quality, we have two different types of variations. One of them is assignable variation, and another one is natural variation. For example, if you leave home every day to go to work and start your work at 9 p.m., you can leave your home, let's say, around 8:30. And sometimes you may arrive your destination or office at 9:05, 9:07, 8:55, 8:56. So of course you don't arrive to office every single day at the exact same time. The reason is that there's some kind of variation. For example, there may be traffic, there may be some pullovers, or you may end up leaving home late and so on. There's some kind of variation in life all the time that we cannot control. And this variation is called natural variation since we cannot attribute to specific reason. But for example, if you are late to work every day by at least 20 minutes, that tells me that there's some kind of assignable variation. Maybe you have a baby and you have to drop your baby to daycare, or you may have flat tire, you need to pump air, or your wife or husband may give you some extra work in the morning that you have to do. So that's assignable variation because you can find an attribute or reason to assign that variation. Again, this is called control chart for attributes because as you see number of inferiors, I can count them, and these are either inferior or good. So it is discrete numbers, and that's why we call attributes. Okay. All right. So let's calculate our situation, whether these are assignable variation or not. But to be able to do that, I would just replicate this. So I will just copy paste this two columns right here, Control C, Control V, perfect. Now I can do calculate the P. So this is my first step. I need to calculate the probability values or P values, okay? This is my step number one. Step one, sample proportions or probabilities. Sample proportions, okay? So to be able to calculate sample probabilities or proportions, I need to divide my number of inferior products by my number of invoices. In this case, it is 1%, 1.2%. If I just double click to copy the formula down, you can calculate the probabilities here, probability of defects or inferiors. Once you do this, we are curious here about assignable variation. Again, assignable variation is variation that I can assign to a certain reason or group of reasons. So I'm wondering, is this assignable or is it natural variation? To be able to do that, I need to make certain calculations. First, I need to calculate my p-bar, which is average p. Okay. In this case, I will take the average of my p values. This is my p-bar, and I need to define my z-score. And maybe you can say this one is my step number 2. To the averages. Now I define my z-score. In general, we choose z-score as 3 because this is my step number 3. Because z-score of 3, normal distribution, if you know, if you remember from average, if you go to 3 standard deviation to the left and 3 standard deviation to the right, the area under that curve is approximately 99%. 99% control limits. So 99% of your observations are within that 3 standard deviation from the mean. All right, we choose in general 3 z equals to 3, but sometimes you can choose z equals to 2, which is 95%, but z equals to 3 is very common use here. Okay. And now I need to calculate the sigma or standard deviation. So to be able to calculate standard deviation, this is a binomial distribution. The reason is that if you look at your basic probability classes, if something is either true or false, we are talking about probabilities associated with that is a binomial distribution, like head or tail kind of situation. So we will calculate our sigma value here, and this is my step number 3. Calculate the standard deviation based on binomial distribution, and n here is not the number of samples. Instead it is size of the sample. The size of the sample. All right. So what do I mean by that? So size of sample here is 1000. Number of samples I have here 25. So that's why I will use 1000, which is my size of sample or sample size. Okay. So now we can calculate the sigma value or standard deviation value based on normal distribution, and that is square root. You don't have to memorize. You can always Google it. Binomial distribution standard deviation. Square root of probability of success times probability of failure. So probability of failure or inferior here is 4.7% times probability of success. Probability of success is 1 minus probability of failure in this case. Okay, probability of failure times probability of success. Divide by sample size. In this case, it is 1000. 1000. All right. So that would give me my sigma value. Let me just double check whether my formula is correct. So I take square root of probability of success times probability of failure divided by sample size. Okay, that looks good to me. See whether we can see the value. The problem here, let me just double check. So, okay, K28. Oh, where the K28 comes from? Sorry. The probability of failure is K2 times 1 minus K2 divided by sample size. Again, probability of failure, K2 times 1 minus K2, which is probability of success, divided by sample size. All right, so this is my sigma right here. So percentage-wise, it is around 0.7%. Now I can calculate my lower control limit and upper control limit, lower and upper control limits. And lower and upper control limits can be calculated by this formula. Let me just insert a comment here for you. So this is step number 5. Lower control limit is equal to P bar average P times Z score, which is number of standard deviation, times sigma or standard deviation. All right. So this is my lower control limit. Okay, so I will calculate also upper control limit in very similar fashion. Only difference is the minus will become plus. Upper control limit, this minus will be plus. That's the only difference. Okay, so I have my formulas. Let's calculate my lower control limit. So lower control limit here is P bar minus Z times the standard deviation. All right, so that's my lower control limit. Perfect. Now let's calculate our upper control limit. Again, P bar, this time plus Z score times sigma. This is your upper control limit. Perfect. So if my p-values are within this boundaries, 2.7%, 6.7%, that is we call natural variation. That's normal. But if we observe any number of inferiors with less than 2.7% or more than 6.7%, then that will make us think that this is assignable variation. All right, so that's it for today. Next presentation, I will talk about the building the control chart for this data. And until then, enjoy supply chain management.